This is the video lecture for Math 3 Unit 4 Objective 3, and we are going to be working with adding and subtracting rational expressions. And initially we'll be doing it with like denominators, so the denominators being the same. So just adding and subtracting fractions. So just a reminder, whenever you're adding or subtracting fractions, make sure that the only thing you're actually combining is the numerator, right? So you would add or subtract the numerator, but the denominator is going to stay the same, right? So the denominator does not change. All we're doing is adding or subtracting the numerator. Okay? All right, so if we have common denominators, so the most important thing for us to pay attention to, which is usually where we kind of struggle, is that it's only the numerator that we are adding or subtracting. And the other piece we have to pay attention to is that if we are subtracting, we need to make sure that we are thinking about that part. That we are subtracting, so we have to really kind of pay attention to the fact that you're subtracting everything in that second numerator, so make sure you're kind of paying attention to kind of a distributive property is really what we're thinking about and what we're working with, okay? All right, so let's go ahead and take a look at just a couple of examples here. So for this first one right here, so we have common denominators, so they both have a denominator of 3y. So when we go to add these, right, because we're adding, so that 3y is going to stay the same, right? So these have to be the same to be able to combine the numerators. And then we're just going to add the numerators. So we're going to do 4 plus 5, which is just 9. And then once we do that, we want to try to reduce it. And then in order to reduce, we would try to just factor it and then reduce any common factors. So there is no factoring to be done because we only have a single term in the numerator and the denominator, so then it's just about reducing. And so here all I'm going to do is, I know that 3 will divide into 9 3 times, so I'm just reducing through dividing. So then my answer would just be 3 over y. All right, and then let's take a look at question number 2. So same idea here, so I have common denominators, right? So common denominators here. And so when I go to do my common denominator, I have to remember that this subtraction is for both the 4x and also for the 3, right? It's for both of those. So I'm subtracting 4x and I am also subtracting 3. So different ways to approach that, but the way to think about that, okay, is that I have a common denominator already, right? So these are the common denominator. So that would be 3x squared minus x minus 2, and then I have to subtract, right? I have to subtract that numerator. So 7x plus 5, and then I want to subtract the 4x, but I also want to subtract the 3. And then from there I'm going to combine like terms. So I can combine together the 7x and the 4x, right? Because those are the same. So 7x and 4x will combine. So that will give me a 3x. And then I can also combine the 5 and negative 3. So 5 minus 3 is 2. And then because I have polynomials, meaning adding and subtracting here, then I want to try to factor before I reduce that. So I'm going to go ahead and do that up here. So 3x plus 2 does not factor, right? No GCF there. So that's my whole numerator. And then my denominator, though, I can go ahead and factor that. So if you're a little rusty on your factoring, you might want to go back and look at some old videos there. So 3x squared will factor to 3x and x. And then I know for my factors for 2 are only 1 and 2. But I need to get those in the right location. So I know the 2 is going to go here and the 1 here through guess and check. And so I need my negative 1x in the middle. So it's going to go like that, right? So that's my guess. It's an educated guess because I've done this a couple times. But if I wanted to check it, right, so this would give me 3x squared when I multiply. And then here I would get negative 3x plus 2x, which is negative 1x. And then 2 times negative 1, which is negative 2. So again, if you're not sure what happened here, maybe go back and watch a video on factoring. And then from there, I can reduce that 3x plus 2 because they're common factors. And so then my final answer is I have an x minus 1 in the numerator and I can leave it grouped or not. And then the only thing left in wait, this is the denominator. The only thing left in the numerator is an implied 1, right? So when I divide that, that's just equal to 1. And so then that would be my answer there. So this would be a good time to press pause and try to do a couple of these and see how you fare. Okay. All right, so let's go ahead and take a look at question number 3. So again, I have a common denominator of 2x plus 7. And then I'm going to add my numerator. So I have a negative 7x, and I'm going to add that to x minus 21. So combine like terms. So if I add these together, I would get negative 6x, and then minus 21, because nothing combines with it. And so now I want to try to reduce it, so I'm going to do a little factoring here. So I can do GCF, so I can pull a negative 3 out of both of those. So that would give me a positive 2x and a positive 7. And then 2x plus 7, nothing factors out of both of those. So I'm going to go ahead and group that. So then I can cancel and divide 2x plus 7 by itself, which would just be 1. So then my answer would just be negative 3. Okay, so again, this would be a good time to press pause and then try to do a couple of these. Okay, and then I'm going to skip 4, but let's go ahead and take a look at 5 and 6 here. So for question number 5, so again I have a common denominator here. So I'm going to go ahead and write that out. So my common denominator is y plus 4. And then I have 3y plus 2. And then I need to subtract both the y and the negative 6. So I have to subtract the y, and then when I subtract a negative 6, that's going to turn positive, right? Double negative. And then combine like terms. So here I can combine a 3y and negative 1y. So 3y minus 1y. And then my constants, so 2 plus 6 is going to be 8. And then all over y plus 4. And then always try to factor and reduce. So for this one here, I can factor a 2 out of both in the numerator, so GCF. So divide out a 2 from both. And then in the denominator, I've got nothing that I can factor out or divide out. So that would just leave me with that group of y plus 4. And then I have y plus 4 as a common factor. So divide it by itself would just leave me with a 1. And so 2 divided by 1 is just 2. All right, and then let's take a look at the last one on this page here. So again, I do still have a common denominator. So even though these are not in the right order, because this is addition, addition is commutative. So even though this is listed as 1 plus 3y, that is still the same as just 3y plus 1, right? That those are equal because addition is commutative. So even though it doesn't look like they have a common denominator, they really do. So then I have that common denominator of 3y plus 1. And then I have my numerator here. And then I want to subtract the other one. But again, whenever you subtract, you need to make sure that you're remembering you are subtracting every single term there, right? Not just the first one. So that means I have to distribute that out, right? So I'm subtracting all of these. So when I subtract that negative y squared, that's a double negative. And I'm going to subtract a negative 2y, so another double negative. And then I'm going to subtract a positive 1, so that would be minus 1. And then now I want to go ahead and combine like terms. So I can add 2y squared with 1y squared. So 2y squared plus 1y squared. And then I have the 5y plus 2y. So 5y plus 2y, so that would be plus 7y. And then finally 3 and negative 1, so 3 minus 1 is positive 2. Okay. And then go ahead and factor the numerator and the denominator. So the numerator is a trinomial. I'm going to do guess and check. So I know 3y squared is only 3y and 1y, and so then it's just a matter of breaking up the 2. So that's 1 times 2. So I either need the 1 here and the 2 here, or the 2 and then the 1. So again, you would do guess and check to try to figure that out. And then if I check it, so that would be 6y plus 1y, which is 7y. And then my denominator, I have 3y plus 1, which has no common factor, so that would just be its own group or own factor. And then 3y plus 1 divided by itself is just 1, and so then I'm left with y plus 2. Okay, and then that's it for that common denominator piece. Okay. All right, and then let's take a look at the last page here. So this one is a little bit tougher. So this is when we don't have common denominators. So these are unlike denominators. So when they don't have common denominators, we have to do that a little bit different. So here we always are trying to find the lowest, right? The lowest common denominator. That's what we're always striving for. And then once we do that, we want to multiply by whatever factor we're missing, and we always have to multiply by 1, right? You can't just multiply by, willy-nilly. So you have to make sure you're always paying attention to what you're doing. And then you try to simplify if you can, and then you treat it like you did that first page. Okay, so always that goal is get that common denominator. So here, for this first problem, I can see that these denominators are completely different, right? And nothing will factor out of them. So because they're completely different, that is going to be my common denominator. Okay? So my common denominator I'm going to use for this first example is going to be x minus 1 and x plus 2. Right, because nothing factors, and so I have to just use each one. So then I'm going to take that first fraction, and I need to get the denominator to be this, so I have to multiply by x plus 2. And I have to do that to the numerator and to the denominator, right? Because this has to be equal to 1 here. And then I'm going to do the same thing for the second fraction. So I have that 2 over x plus 2. And again, this denominator needs to turn into this, so that means I need to multiply by the piece missing, which is x minus 1. And then once I do that, I need to simplify, right? So simplifying is important. So that usually means to distribute. So some people on this step, they think simplify means canceling because that's what we typically mean, right? But we mean to distribute that numerator, right? So that's what I mean by that. So distribute that numerator in that simplifying part. So I'm going to go ahead and do that. So we're going to distribute that 3. But not the denominator. And then I'm going to distribute the 2, but not the denominator. All right, so now this turns into a problem just like the front side. So I have a common denominator, and it doesn't matter that these are in different orders, it's still a common denominator. And then I have that first numerator. And then now I'm going to subtract everything in the second one. So again, when I subtract, make sure you're distributing. So I'm going to subtract 2x and then subtract negative 2. So that double negative makes it a positive. And then from there, we're going to go ahead and combine like terms. So I can go ahead and combine 3x and negative 2x. And then 6 plus 2. And then nothing factors here, so then I have like common factors, and so then that would just be, all that I have for that particular problem, and so that is the last of that, okay? So I can't simplify that any further. All right, let's go ahead and take a look at question number 1. So for here, so for my common denominator, so for number 1, so I'm going to do that above it here. So I start with my first fractions denominator, which is x and x minus 5. And then if I look at my second one, I also have a 5 here that's not over here. So that means I need to include that 5 as well. So I wouldn't want to add it to the end because that looks weird, so I'm going to add it to the front. So my common denominator has to include the x minus 5, the 5, and then there already is an x minus 5, so I don't need to have that as well. So then I need to get both of these denominators to look like that. So that means for question number 1, the first fraction, it doesn't have a 5, so that means I need to multiply the top and the bottom by 5. And that's to get that 5x. And then over here, I need to multiply the top and the bottom by x, and again, it's to get the 5x. They already both have the x minus 5. So now multiply your top together, so that would give you 25 over 5x, and then x minus 5. And then subtract, so your x is here, so x squared, x times x. And then I have my 5x and x minus 5. Okay, so then now we have a common denominator, right, because those are exactly the same. So then I would just subtract my numerator. So I have 25 minus x squared over 5x and x minus 5. And then now I just need to simplify that. So I'm going to just rewrite this, so that would just be negative x squared and then positive 25, right, because I always want my variable first. And then I want not only my variable first, but I also want it to be positive, right? So I need to factor that negative out. So let me just use some space up here. So I'm going to take out that negative. And then this is just a difference of squares, so I can factor that again one more time. And then the x minus 5's reduce. And so then I'm left with just negative x plus 5 over 5x. All right, so let's go ahead and take a look at question number 2. So I'm going to actually do 2 and 4 together because they're similar style problems with this kind of weird negative. And then I'll go back and do 3. So I'm going to do 2 and then 4. So if you are pressing pause, keep that in mind when you're pressing pause and checking, is that I'm going to kind of jump around a little bit here. So the first thing I want to do here, so this is backwards, right? So I need to fix that problem. So I'm going to rewrite this and just get that kind of in that right format. So that's really negative x and then plus 9. So I just want to get that in the correct order, so I should always have my variable first in common descending order, and then I want to make sure that variable piece has a positive, right? That leading coefficient is positive. So that means I can factor a negative out of that. So I'm going to go ahead and do that. So something that looks like that, right? So I have a couple of different strategies here that I can do for this particular problem. So what I am going to do is, in order for these to be the same, I need a negative introduced, right? So these are not the same right now. So I can do one of two things, actually one of many things, but I can multiply the top and bottom over here by -1, so these would be the same. But instead, and this is a little bit different, kind of thinking outside the box, is I'm actually going to multiply this by the -1. And that's going to get rid of the negative to make it match this one. So instead of like introducing a negative, I'm going to get rid of the negative. So that's a little bit different. So I want to get rid of that negative, so I'm going to do that by multiplying the numerator and that denominator by -1. And that's going to help me get that common denominator. So this is going to stay the same. And I actually make the problem a little easier because of that. So then when I multiply that, I'll get -3x, and then here the negatives will cancel, giving me that x minus 9. And so when I do that, I actually have kind of a simpler problem that I'm working with. And so now I'm just going to go ahead and combine here. So I have common denominator, so 7x minus 3x, and then over x minus 9. And that's it. All right, so 4 is very similar. So if you want to, this would be a good time to press pause, try 4, kind of using that strategy for number 2. Okay, so again, this is my kind of backwards, right? So I'm going to fix that. So I have x squared minus 4, which is going to factor. And then I'm going to flip this around. And then I'm going to factor a negative 1 out of that. Okay, so now to get these to align or match up, so I'm going to multiply by that negative 1 just like I did up above. So I'm going to multiply by negative 1. But I also need to get that common denominator, so I need one more factor. I need to get that x plus 2 over here as well. So I'm trying to make this guy look like this guy. So I'm multiplying by the negative to get rid of it, and then I'm also going to multiply by x plus 2. So then when I do that, I'm going to have 4 over the x plus 2x minus 2, right? That didn't go away. And then I have this negative 1 times 5, and then that x plus 2, right? And then this double negative will turn positive, and then again I have x minus 2x plus 2. So I'm doing this kind of in 2 steps, and I could have certainly done this in 1. And then I have a double negative here, so that'll be end up being a positive. So then now I have that common denominator. And then my first numerator. And then I want to distribute that 5 in, right? Always distribute the numerators. That never goes away. And then I can combine like terms. So I will have a 5x plus 14 all over that common denominator. And that's it, because 5x plus 14 doesn't have anything common, right? So that would be the end of that. Okay. And then let's go ahead and take a look at the next one. So now I'm going to backtrack to question number 3. So let me zoom in just a tiny little bit here. Okay. All right, so for this one, again, I want to get kind of that common denominator. So between this first one here, I have 5x to the 8th and 3x to the 6th. So it's going to need a 5 on this one, so I'm going to multiply by 5. And then this one's going to need that 3, so I'm going to multiply by 3. And then here for my x's, I have 8 x's over here, but I only have 6, so this is going to need a couple more, right, so that those will match up. So then I need 2 more, so that would be 5x squared. So now when I multiply, I'm going to multiply my numerator and my denominator. And then on this one, same thing. So that will give me 20x squared, and then over 15x to the 8th. And then now they have matching denominators. So when I add my numerators, I want to get this in the right order. So that 20x squared can be first, and then plus 18, right? I always want to be in the right order there. And then all over 15x to the 8th. And let's see, I could do a GCF here. So what can I factor out? I can factor out a 2, I think, and that's it, right? Which ends up not being helpful, right? Because then nothing reduces. But that's okay. So I still checked it. And so actually either answer would be fine because nothing reduced here. Okay. All right, and then let's take a look at the very last one here. So for this one here, I'm going to go ahead and factor this, and I'm going to put this in the right order as well. So I have y minus 2 over y plus 1, so that one's all good. And then minus, and I want to get that negative 12y first, and then plus 3. And then factor the bottom. So factors for 2y squared are 2y and y. And then my factors for 3 are 1 and 3. So I know it needs to go 3 and 1, and I want it to be negative 1 in the middle, so negative and then positive. And then again, if you're weak at the factoring, you know, go back and look at some of those videos to kind of help you with that part. But then once you think like, oh, I think that's right, then you should distribute it out and check it. Okay. All right, so then this fraction here, it needs to get that 2y minus 3. So I'm going to just write that in like that. And then remember, you always want to distribute that numerator, right? Distribute that numerator. So I have to distribute this out, so y times 2y, and then y times negative 3, and then negative 2 times 2y, and negative 2 times negative 3. And then distribute the negative in, so I'm going to distribute the negative in over here, so that'll be a plus 12y and a minus 3. And then all over that common denominator. And then you want to combine like terms and then try to factor and reduce. So then I only have a 2y squared, and then I have negative 3y and negative 4y, and then the 12y, right? So all three of those will combine. So that's negative 7y plus 12y, which is 5y. And then 6 minus 3, which is 3, all over that common denominator. And then, of course, my last step here is to go ahead and factor the numerator, right? So, and then try to reduce. So I know I could do 2y and y, and 3 and 1, both positive. And then my last step, of course, is just to cancel any common factors, which in this particular problem is y plus 1. So then my final answer would just be 2y plus 3 over 2y minus 3. And that's it for this lesson.